Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problem minimum domino rotations for equal row. Its index is 1007 and it is the medium problem of the LeetCode. Okay, so without wasting our time, let's discuss this problem. Also, one thing I need to add is you need to know how we are going to use the greedy approach to solve the problem efficiently. Okay, so in a row of dominoes, tops of I and bottoms of I represent the top and bottom halves of the ith domino, and the domino is a tile with two numbers from 1 to 6, one on each half of the tile. Okay, so you can see there is an arrangement given in this figure. So if the value is 2 over this position, it represents the top value of this particular domino, and correspondingly we have this bottom value which is 5 that will be given to us. Okay, we may rotate the ith domino so that tops of I and bottoms of I swap values. Okay, our rotation is going to be defined as swapping the value of the corresponding domino tops value and with its bottom value. Okay, and we need to return the minimum number of rotations so that the all values in tops are the same or all values in bottoms are the same. If it cannot be done, return -1. Okay, so we need to find out the minimum number of rotations, that is swapping the top value and the bottom value of the particular domino so that the all the values in the tops array, you will be having two arrays, you can see tops array or bottoms array will be the same, and if we are not able to do that, then we need to return -1 as our answer. You can see that max length of the array is 2 into 10 raised to the power 4. So we need to build an efficient solution involving complexities as O of n or O of n log n. That would work best in this case. O of n square solution will not pass. Okay, so let's understand this problem with example. So I will take this example from the sample. Okay, so we would having the top value as 2. Let me write down 2 1 2 and 4 2 2 4 2 and 2, and similarly we would be having the bottom value as 5 2 6 2 3 2. Okay, so let me choose some another color. 5 2 6 3 2 2. Okay, so the problem statement says that we need to swap the values between this tops and this bottom, and we need to make all the elements in the either this top array or in this bottom array. You can see this is top array and this is bottom array, all the values being same. Okay, so there are one of the possible ways you can do is like, if you can observe, fix the value of 2 over these positions. Okay, so you'd be having 2 over this one, 2 over this one. Okay, let me just cross check it out whether I've written the values correctly. Okay, 2 1 2 4 2 2 2 1 2 4 2 2. Okay, and in the bottom one, 5 2 6 2 3 2 5 2 6. You can see, yeah, I've written the wrong. You can see 2 3 2 is the correct one. So let me just erase it and correct it. 2 3 and 2. Okay, so we need to make all the values in tops and bottoms areas equal. So if you look out for this 2 value, you can see we can make the value 2 be filled in either top or the bottom one. Okay, you can see how we are going to do that. Okay, so consider filling this top array all with 2. You can see this place is already occupied, this place is not occupied, so you are going to do one swap operation. So I will write down 1. This is already occupied, this is not occupied, but 2 is present in the bottom array at this corresponding position. So I will do a swap operation again, 1, and again 2 is present over here, 2 is present over here. So what is the minimum number of operations, like what is the operation required to make all the 2's appear in this top arrays 2? Okay, similarly what will happen if I will try to make try to fill the value to all the positions at this bottom array? You can see I need to do one operation at this position, one operation at this position. Note that the operation is being defined as swapping the values of this tops of I and bottoms of I, which is the swapping the values of top and bottom position of the particular domino, and this position. You can see it is coming out to be 3. So minimum is 2, which is our answer. So how do we guarantee that we have a solution? Okay. So one thing that you need to understand that all the values in tops as well as in bottom must be same, right? So either 2 or 5. If I will try to fix out two numbers 2 and 5, then we need to check only these two numbers that we can make that is we are going to make these two numbers filled in either top array or in the bottom array. Okay, so suppose, let me take a counter example and try to prove it. Suppose we have a number called 5 over this position, and I need to make all the elements equal to 5 either in this top array or in this bottom array. Okay, so now just think about the case like if 5 is present at this position, so this position is fulfilled, and if you move out to the next position, 5 is not present in any of the positions either in the top one or in the bottom one. Okay, so it contradicts that if we are not having any value that we are searching for, let's say the value val we try to fill in tops array or in the bottoms array, if we try to fill this value, and if this value is not present in both this tops of I and bottoms of I, then it is not going to be possible to make this value appear in all the positions of this tops array or in this bottoms array. Okay, so how do we find this demanding value val? Okay, as I've already said, if this val is present in tops, all the positions of this tops array or all the positions of this bottoms array, right? So this value must be present in either of the position of this tops of I or bottoms of I for every particular I, right? Okay, so how do we find this demanding value val? Okay, so this demanding value val must be either tops of 0, or bottoms of 0. We need to check only these two values. Why we need to check only these two values? This is because if you're not able to, like if you're not checking these two values, then any other value will always contradict the positions, contradict the values present at these positions. Okay, so tops of 0 is actually 2 and bottoms of 0 is actually 5. So we need to check val which will be either 2 or 5, only these two cases. Why don't we check val as 6? We don't check val as 6 because if you check val as 6 and when you come at this position, 6 is not present in tops of I as well as 6 is not present in bottoms of I. So this will give you the incorrect case, like this 6 is not a demanding value. Okay, so we are going to fix some demanding value which is tops of 0 and bottoms of 0 and try to check it out whether this can be our answer or not. Okay, so our demanding value is val and we need to check whether this can be our answer or not. So how we are going to do that? So it is very much simple. So if val is our demanding value, we will just iterate by considering every time this val is present in either in tops one, then we'll find out the minimum value. If this val is present in bottom one, we'll find out this minimum value. Consider val as, let's say, 5. Okay, so if value is 5, so 5 is present and we need to make this val appear all in tops array. Alright, so 5 is not present in this position, so we need to do a swap operation. Again, if 5 we need to make 5 appear at this position, but 5 is not over here as well as 5 is not over here, so it means that we are not able to make 5 appear in all the positions in the tops array. So we will return some bigger value called int max, so that it will denote the 5 is not a correct value. Okay, similarly if you try to fill 5 in this bottom position, you can see this is already present. At here also you are going to have the value 2, but 5 is not also present over here, so swapping operation is still not feasible. So you are going to return some int max value because 5 is not present in either of these positions. Okay, but you consider some demanding value 2, then you will see that if you are trying to fix 2 at all the bottom array positions, you need to do swap at this position. This is already done, you can see. So this is you need to swap at this position, as well as this position. So your minimum operations to make all the bottoms array equal to this value 2 is 3. And similarly, if you do at this position, you will get the value as 2, because you will have 4 values which are already equal to 2. So remaining positions you need to do swap operations, and these are this position. So the answer is 2. You had to take minimum of 2 and 3, which is 2. So this is the operation that you need to do. Okay, so let me show out the code how we implement all that efficiently. So either we are going to use two demanding values, tops of 0 and bottoms of 0. Okay, so my demanding values are val1 and val2, and n is the size of the array. So I will iterate from 1 to n minus 1, and check if val1 is not equal to tops 1 of I and val1 is also not equal to bottom 1 of I. So val1 is not the demanding value, so we will make val1 as minus 1. Okay, and similarly val2 is also not equal to either of them, then val2 also becomes minus 1. Minus 1 will denote that this is not a correct demanding value. Otherwise we will always end with some positive integer val1 and val2 being our demanded value. Okay, note that I am taking tops of 0 and bottoms of 0. You can take any particular index I, and that can be our demanding value. Okay, so as I've already proved by contradiction, we can have only at max 2 demanding values. Okay, so yeah, we need to minimize our answer with val1 as well as val2. Okay, so what I've done is, like, I've defined a solve function, and if so the value that demanding value is minus 1, we will return int max. This will denote that the demanding value is not suitable to get the answer, like making all the values in tops array equal to this value, as or all the values in the bottoms array will be equal to this value val. Okay, in that case, if val is minus 1, we need to return int max. Otherwise, find answer 1 and answer 2, which is the minimum number of operations that you are going to do to make the either tops array equal to this val, all the positions will contain this value val, or bottoms array will do the same. So I will make it as n, and when the value is exactly equal to val, we will decrement it. You can see. So finally we need to return the minimum of both answer 1 and answer 2. So this will give you all test cases passed. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.